Okay, it's 1 o'clock Central Time. Welcome everybody to our next edition of the HDF Clinic. And as always, I checked earlier, there weren't any questions submitted. That's fine. We'll get going anyway. But I'm going to pause for a moment, and if any of the people who joined, welcome. If you have a question related to HDF5 about your applications, performance issues, whatever, now is your time to speak up. Now is the first time to speak up. I'll pause periodically and see if there are any questions. Any questions? No? Okay, then we'll just go through our usual routine. Last week's highlights. As we always do, the only announcement pending an event I'm aware of is our call for papers and presentations. I should probably rename that for the HUG, the HDF Users Group event in October. And the deadline for papers has changed. It used to be June 1st, which has passed, but it's been extended to June the 24th. And for just presentations, the deadline for abstracts remains August 1st, and that's still out there. So please, if you think, and I'm sure there's no shortage of good ideas and things worthy presenting at this event, sharing with a wider audience, I think this is a great opportunity. Okay, what's been happening on the forum? There were many interesting topics, discussions going on. One is actually related to HUG. Some of us got together and we thought, wouldn't it be nice if we at this HUG event could talk about what albeit maybe simple or small change would make a big difference in users of HDF5, that is, in their workflow, how they use HDF5 and so forth. And we got some great comments and suggestions already. Here are a few examples. So I linked the thread here, so I encourage you to go to the forum and chime in if there's something not covered here that's important to you. But people were talking about, for example, making revisions to the filter interface. I think that's a good idea because, times have changed and there seems to be great interest in implementing new filters and different filters, and the interface may not be fit for modern requirements anymore. And let's bring them together and think about how we can revise it and move forward. Another interesting discussion around, also related to filters in a way more broadly to plugins, updates to how the HDF5 library and some of the tools interpret the plugin path. So for those components that are dynamically loadable at runtime, there are a bunch of environment variables, and HDF plugin path is sort of the most basic one, where you can basically specify where you want the library to look for shared libraries or DLLs in Windows and so forth. And there were some suggestions. So for example, by default, this plugin path does not include, for example, the working directory as in other scenarios and other systems. Now, there are pros and cons. There are people might have security concerns. There are, but hey, this is a discussion, and so I think we want to hear all sides of the argument. And if it dramatically simplifies people's lives, then that's definitely something worthy consideration. Another very interesting suggestion by one user was this concept of an amalgamated source. I think whether it's feasible remains to be seen, but it's certainly an interesting idea. This concept of an amalgamated source, and I think one of the examples that the commenter referred to was SQLite, where you basically create a single source file for the entire HDF5 library, for example. So right now, of course, the code is backdoored into modules, and there are header files and source files and so forth. And of course, especially for a C compiler, that certainly limits, among other things, the size of the compilation units that the compiler sees and where it can make optimizations and so forth. Whereas with amalgamated source, where you would basically create one giant C file, I don't know how many hundreds of thousands of lines that would have, it would definitely be in that range, although I think periodically during BOFs at SC, for example, I think we published some statistics on what fraction in terms of lines of code of the HDF5 library is testing code and what fraction is library code. And I think it's pretty evenly split, maybe with a little upside on the testing code. But that's certainly a very interesting idea, and we should discuss this and see what people think. Another one, modern language bindings for Fortran. I found it interesting that the commenter referred to Python, and yeah, with, for example, with H5CPP, that's a reality. And I don't know, since I'm not a Fortran programmer, I don't know what kind of facilities the Fortran language offers nowadays to make that happen, because that requires certain infrastructure that may or may not be available in Fortran. But hey, this is a discussion, and hopefully Fortran experts will show up and can offer an opinion on what it would take to create modern language bindings for Fortran. And then chime in. This is really what the plan is, to basically keep that thread going on the forum, and then at some point in the run-up to the event, basically compile all these ideas, and then hopefully most of the commenters, or as many commenters will show up at HUG, and then they can speak for themselves to these different topics. And if somebody doesn't show up, I will try to sort of be sort of a proxy, or try to represent that topic. And so this is a very interesting topic to follow. Another topic is, yeah, somebody commented on, and we've had that a few times, is that he or she has an HDF5 file where the tools are complaining about that they can't open the file, and it seems to be an issue related to Swimmer, where when the file gets opened in Swimmer mode, there are certain bits set, actually 2 bits in the what we call the file consistency flags byte of the HDF5 file. And these bytes are usually cleared when the file is properly closed at the end of an application termination or something like that. However, if the application does not properly close the file, then these bits may not be cleared, and then that is sort of a warning sign to other applications that are trying to open that file. If they see that those bits are set, then they will typically terminate and say, well, there's something going on here with this file. And there are then different options that you have. Number one is there is a tool called H5 Clear, where you can clear these bits, and that should resolve the issue. Although having the ability to clear these bits is sort of a double-edged sword, in the sense that unless you are really confident that the file is otherwise intact and consistent and so forth, you're not really helping yourself, or you're not helping anybody by clearing that bit. So that's an interesting issue. And of course, there is more to this story. Well, first of all, I would say it's poorly documented. There are sort of some documents like the swimmer design document and so forth that vaguely make references to this behavior, but then also in the course of 110 releases, I think we've sort of flip-flopped on file locking. It was originally introduced as part of the swimmer introduction, just to make sure that worked correctly on file systems that support file locking. But then it caused a lot of issues for users, and we took it away, and we sort of then we sort of introduced an environment variable where you can set it, where you can, through the setting in the environment variable, indicate to the library whether you want to use it or don't want to use it. And so there is just, since there was a little bit of this back and forth and that change in direction, that I think it's overdue. And maybe that's a good topic for one of these clinics to come back to this and talk about currently what is the state of the art, what is happening, what is sort of the life cycle, if you wish, and just to clear this up. But so we will see where that goes. And then there is this other thread here where a user is still working with H5Py and MPI, and he can't work out exactly how to in parallel write to different data sets and so forth. And so that's ongoing. But the issue here is, yeah, it's certainly, he definitely should use Python if that's what he's comfortable using. But as I keep saying, there are limits to how much support we can offer, because we are not the H5Py experts. And it's great to post a minimum working example in Python, but yeah, if you give us a piece of C or Fortran, I think we can handle that. But with Python, since we don't know about necessarily the internals of how some of these methods are implemented and so forth, there's only so much help that we can give. But it's an interesting issue. Okay, and we will resolve it one day, I'm sure. Okay, I have prepared in our sort of tips and tricks section and insights something about user block. But before I do that, I'm going to pause and ask again, are there any questions around HDF5 for your application? Anything HDF? Now is your time to speak up. Okay, either everybody is keen to learn something about user blocks, or there aren't any questions. Okay, I'll just press on. User blocks, that's sort of, it's an interesting feature. I would say maybe it's maybe more for advanced users, but it's sort of a hidden gem, because it's not something that I personally or many people use frequently or every day, but it's sort of, it's an interesting feature that is to a degree unique to HDF5, I would say. And it's sometimes just that thing that makes all the difference and makes things a lot simpler. And of course, as with all good things, there are also situations where you can abuse it, or where you can get yourself into a lot of trouble. So again, take that with a pinch of salt. This user block is sort of in line with the idea, if you look at HDF5 files as these containers, that one of the goals, of course, is in an abstract or in a metaphorical sense, the purpose of a container is sort of to create these self-contained units, to keep things together. And this sort of, I would call this part of the HDF5 mantra, is of keeping things together, more specifically along the lines of this sort of concept of self-describing data. You definitely want to keep the metadata and the data together to really make data interpretable and make that interpretability portable across wherever that data goes. The metadata goes with it, and it's possible to understand and interpret and read and analyze the data and modify the data if you've kept things together in that way. And frequently we find ourselves that obviously the reality is not all data is HDF5 data, whether we like it or not. And oftentimes you have sort of ancillary, be it documentation or other data, that now that you appreciate in a way the keeping things together HDF mantra, that you would like to add to this mix of keeping things together. And there are obviously different ways how you can achieve that. And the obvious one is, for example, you could create a tar archive or a zip file or something like that, and then sort of keep everything together. And if you want to share something with a colleague, for example, assuming the thing is not terabytes or something like that, then you might send a tape in the mail or something like that. But let's assume it's not gigantic. Then putting it into a tar archive or zip file is sometimes a good idea. Now, of course, that approach also sometimes has problems. So, for example, assuming that this additional stuff, this documentation and so forth, is either sometimes that you don't need very frequently, or in terms of size is much, much smaller than the HDF5 file itself, then the problem that creates is if you want to access the data, you can't really access the data without first unzipping, for example, the file. So if you just want to reach into that HDF5 file that's part of that collection and read just the data set element, you have to first unzip it, and then you can access the HDF5 file and so forth. So that's not good in that scenario. And so the way I put it is in a way, and that gives me the transition sort of to user blocks. In a way, HDF5 can be on the outside or the inside, in the sense, in the case of the zip file, the HDF5 file is sort of on the inside, in the sense there is another outer shell, like the zip archive or the tar archive or something like that. And then you have to live by the constraints that that outer shell imposes on you. Or you can use, and now we are getting to these user blocks proper, you can sort of maintain that idea that you are dealing with an HDF5 file, but in that HDF5 file, you can sort of carve out the compartment where any application can sort of do as it pleases inside of that compartment in terms of reading data, writing data, putting a PDF file in there, putting non-HDF5 data in there, and so forth. That's all fine. That's where sort of the HDF is on the outside, because the HDF5 library won't mind that. And it won't, when I say won't mind, in the following sense, when you create an HDF5 file or take an existing HDF5 file, what you can do is the way how the library detects whether a given file is an HDF5 file, it basically reads as many binary file formats have a signature, it looks for that signature that is documented in the file format specification. And if it finds that signature, then it sort of starts interpreting that stream of bytes and makes sense of it as an HDF5 file. Now, that there is no, however, that requirement is relaxed. That requirement that sort of at byte offset 0, you have to find the HDF5 file signature. That requirement is relaxed in the sense that the file format specification says that that signature can be offset by a power of 2 bytes. It has to be at least 512 kilobytes, but after that, it can be any power of 2. So that is that compartment that I'm talking about that you can create, and we will see that in a moment. You can do that programmatically, but you can also do this with a tool or tools on the command line. And so you can create this compartment, and then external applications or non-HDF5 applications can sort of embed content into this compartment, and the HDF5 file, the HDF5 library won't mind, because yeah, it will just say, okay, there's no signature, no HDF5 signature at offset 0. I'll just check 512 and then seek to other powers of 2. If it reaches the end of the file, then the library will just say, well, that doesn't look like an HDF5 file to me. But at some point, it will locate that signature maybe, and then it will just ignore this user block, and everybody's happy. Now, again, I'm not talking about the programmatic way here, which goes over creation property list for a file. I'm talking about using tools. So if you want to experiment with that concept, and maybe next time, maybe not today, we won't get to specific use cases where you might use that, but yeah, we can talk more about use cases. Today, let's just talk about how you would do this using tools. Again, last time we talked about H5 repack, that you can experiment with compression and other sort of free space management options and so forth. And it's always good to try something without writing a lot of code. And in the case of the user block, that's the purpose of the jam and unjam tool. H5 jam is the tool that allows you to create such a user block and take an existing file, for example, and put it at the beginning of the HDF5 file. And the tool will internally do all the shifting of the file format signature and so forth. Or once you have you're presented with a file that contains sort of non-HDF5 content in this user block, you can use this tool called H5 Ungem to recover that content from the file. And I just included in the notes here, it's just the usual. I think if you run H5 gem, dash version, it will tell you something about the library version. So actually, it doesn't. It's some tools. Yeah. So this is a 112 build, but yeah. So some tools support dash version. This one doesn't. Okay. And then, of course, for the creation of this user block, you basically have to specify the HDF5 file to the content of which you want to prepend user file content, the actual payload that you would like to put into that user block. And then there are some options. You can specify a new output file, or you can clobber or overwrite an existing user block, which again, I would caution you not to do initially. And especially if you try this, make a copy, don't take your most important HDF5 file to try this. So I have a few simple HDF5 files here. So let's take, for example, I have a file here called page HDF5. So let's take a quick peek at that. Page.h5, it's just something that I wrote. So you see, if you run it with those options, at the moment there is no user block. The user block size is 0, and there's just one data set in here that's contiguous, and that's all good. And so let's, for example, let's say, since it can be any binary content, I imagine this file paged.hdf5.c is the file, the C source code that actually after compiling, created this file. So let's say, for example, we want to create a file. I'm going to call this userblock.h5, and I'm going to prepend that page-hdf5.c file to this HDF content, and that should give us a first example. So I'm going to say h5gem. Our input file is page.h5, and my user block content is in page.hdf5.c, and I'm going to call the output file, for example, I'm going to call this user block.h5. Okay, that's done. Let's quickly run h5 dump on it to see what we are looking at here. pbh user block.h5. So good news is we have now still a file that has the test data set and everything, and h5 dump is not complaining, so h5 dump is content with that this is an HDF5 file. And here we can see previously the user block size was 0, now it's 1024, which tells me that that source file page.c was probably greater than 512 kilobytes, and so the next greater power of 512 bytes, I'm sorry, the next greater power of 2 would be 1 kilobyte or 1024 bytes, and the tool just detected. So let's take a quick look here. Yeah, so this is 921 bytes, which is greater than 512. So the user block, as we said, has to be a power of 2 greater than 512 bytes, and the next power of 2 would be 1024. Let's convince ourselves that this text file here is really part of our user block file. Well, we could use, for example, there's a simple Unix tool called head. So let's look, for example, at the first 10 lines of this file called what we call userblock.h5. And here we go. So the first 10 lines of this file look to me a lot like source code. So if I do the same thing with our paged hdf5.c file, lo and behold, those are the same first 10 lines. So that worked. So now let's quickly, before we wrap up here, do the reverse. I said we can use h5 ungem to actually extract that user block content from our user block file. So then h5 ungem, yeah, h5 ungem dash help. Okay, in file, out file, if we want to strip that, but I believe, actually, off the top of my head, if I specify no output file, I think it will just extract it. Let's try it. It will just extract that user block and actually not do anything else to that file, but that's why we are here. h5 ungem, so our input file is userblock.h5, and our user file, let's call it source.c. And if we run that, oh, input ungem user block. Really? Oh, it's there. Ungem-i in file. Maybe let me specify an output file name. My hunch is that this is actually not correct, so it wants an output file, but we are getting the wrong error message. See, this is, well, we'll report a bug if that's the case. So let's specify an output file. look at our source.c, and that's our source file. So, and then what you see is these guys down here, these strange looking characters. This is just the padding, because obviously the user block is 1024 bytes. And so we are getting a bonus here. we are getting our original source file, which was 920 something bytes. And then we are also getting back these padding bytes. And that's one of these things, if we want to talk about use cases next time, we can talk about. So if you really want to use this feature seriously, you have to be aware of that. Yeah, when you, for example, read a user block, you get potentially some padding bytes, and then you have to implement or think about a protocol, if that's important to you, to distinguish between these padding bytes and the actual payload, how to do that. And we can talk about how to do that. There are many different ways to do that. And anyway, so that I think concludes our quick overview of user blocks and the tooling with H5Jam and H5Unjam. And I thank you for coming. I encourage you to come back with lots of questions next time. I think my mental bookmark today is that, yeah, based on that discussion that will, I think, unfold on the forum, let's talk about file locking and sort of the life cycle of a file with Swimmer and so forth, with respect to these file consistency flags and so forth. That might be of interest to other users as well. Thanks for coming, and I'll see you next time.
Thanks, Gerd.
Yep, thank you.